Yeah, I think Philip, I will answer Philip while you look if you want for the graph. The idea is that we would like to have universal quantum gate will be any set of gates to which when you apply any operation on a quantum computer, you can reduce it to that set, right? Basically that any unitary operation can be produced or expressed as a finite sequence of these gates that we are keeping. Like I was saying, the U1, U2, U3, this C-node, Hadamard, and phase shift, for example. When we say can be expressed, since I only want to have a finite set of quantum gates, instead of really expressing it, we will need to approximate with any sequence of gates. And there is a beautiful theorem that I was going to mention, and then I didn't mention, but Solovay-Kitaev theorem that guarantees that this can be done efficiently. So that's the idea of universality.
Could you say the name of the theorem again, please?
Yeah, let me put it in the chat if okay. You want. It's the name of two people. Let me see. Solovay-Kitaev. Kitaev was the second one in the definition. Yeah.
Andrei Kitaev.
Yeah. And in the modular category, we also look at this universality, and that's why this is the relation also with the braid group, because when you have a modular category, you have a braid. You can have this commutative tensor product that you achieve it by a braid. And you look at the representations of this braid and you see if you can get to certain finite thing using that braid. So there is a counterpart. Yeah.
Thank you very much for explaining.
Any other questions for our speaker today? We have a bunch of people, our usual. So we have Jamie, Ravi's on. So anybody that we haven't heard of that's new to the discussion, feel free to come on. And then Anna, if you have anything else.
I had just one question, Kevin. Julia, does the work you've done, does that feed cleanly into traditional methods of formal methods in traditional software engineering, or provide any other groundwork for something resembling that?
What I have done, to be totally honest, is more on the math sides, but I do think that there are some potential. For example, okay, one of the things is this thing about the universality that we could detect in this way. Then there is other people working more on the quantum information side. This side that I was telling you of the story is more on the algebraic side. But I think there is also a lot of potential in the analytic side of the story with all the von Neumann algebra, subfactor, and these kind of things. So a lot of people work on these kind of problems, quantum games, quantum. Sorry? Someone asked me?
No, I was trying to find a book called Essential Mathematics for Quantum Computing, and it didn't come up.
And then, for example, there are some results on how we can detect non-abelian statistics from looking at certain degeneracy of things. So I do think that there is potential, but sometimes what I was saying yesterday in Quantum Latino is like, I feel like we need to talk more, mathematicians, we need to talk more to people working on other aspects. I know that now, for example, Microsoft is really working with like engineering or things like this, but usually I talk to other math people or to physicists the best sometimes, but I do think that it will be nice to talk to other people that ask us questions, because that's kind of our job, to be able to solve questions or solve problems and have the interesting problems. It's sometimes the big thing when a problem comes from motivated from someone, right? You have some extra intuition and you have more like